Hi, Eric from Rise. I'm excited to talk with you about improving safety and reliability in your LM applications. So why does safety matter? For customer-facing LLM applications and services, safety is now a requirement. There's many different posts on social media and news outlets covering how new LM systems that don't guard for safety output responses that recommend eating glue, recommend discounts that you otherwise didn't actually recommend, or fail to understand user queries for what they're actually trying to order at a restaurant. And there are many ways to measure safety and relevance in your application, right? In every single part of the LLM application chain, from what the user input contains, what document chunks that you're retrieving to put into the context window, to what does the response contain, and what is the qualitative outputs of the response. So being able to measure relevance or correctness or hallucination or toxicity are all different ways to measure safety and relevance to your application. And today, there are many different evaluation benchmarks across the various different models, such as MMLU or LM-Sys Chatbot Arena, as well as specific data sets tied to bias, harmfulness, or harmlessness, and toxicity. But these evals only get you so far, right? They are meant to compare different chat models against each other, and they're directionally accurate. But the only thing that really matters is how well it performs on your task. How an LM model eval is generated is based off of a set of thousands of different questions where it generates answers and it's annotated with a score of whether or not it's accurate or not. Whereas a task eval is based off of your context, where the user is in the journey of using your application. What prompt template are you using? Where are they within the conversation? Is it a background task, or is there human in the loop, or is it an actual chatbot generating a response to the customer support agent? Based off of that context, the real devil is in the details of how it only matters for how it performs on your task. So in order to actually determine this, you need data to prove whether it's working. Here's an example of a data set for a chatbot that helps you book a hotel based off of the dates that you want to book it for and the destination that you want to go. And on the left-hand side is the user input query. The middle is the context that the retriever returns in response. And then the response is the LM output that was generated to respond to this user query. And then you have a set of ground truth labels to actually determine, is this query accurate or not, based off of the assertion or criteria that you want to judge it for. So given this data set, or given your task, how would you actually benchmark whether or not your LLM application is working? And the way to benchmark it is to base it off of what you believe is a good enough user experience. An example of this is for GitHub Copilot, where when it does autocomplete within your code, it doesn't always have to be correct because there's a human in the loop. It's very easy and forgiving. If it recommends the wrong autocomplete, then the user can just continue coding as if the autocomplete did not exist. Whereas if you had a LLM engineer agent like Devin, which is actually coding on your behalf and you're delegating a much more abstract task, that floor for what good enough is for users to retain on that experience is much higher. So the benchmark is not what benchmark exists on the model LM eval, but it's actually whether or not, if it benchmarks against your task for the outcomes that you're trying to achieve, then that's good enough, right? And for safety cases, that could be 0% of the time, or it could be 2% of the time, depending on your application and how bad the offending output is. So let's talk about how do you actually build safety into your LM application. The AI engineering loop today, the reality is, so let's talk about how most AI engineers start with LM applications and services. They create a prompt to help achieve a certain outcome, whether it's summarization or data extraction or building a chatbot support agent for a specific use case. And the reality is that once you get the demo working, creating iterations and refinements are generally non-deterministic. So you don't know whether if by changing a prompt or a model or a retrieval step, are you going to break a use case, or are you going to degrade performance? So many of the common pains with developing LM apps are the same pains. Many of the common pains for trying to improve safety and reliability in your LM applications are the same pains with just developing LM applications in general. When you're just trying to get something working quickly, you don't have any visibility into what's actually breaking and what's working. Once you have a demo, then you need to be able to evaluate, is this demo actually reliable in all use cases? Or is it actually only work in the specific case that I gave it? And then once you feel confident in your application and you want to release it to users to actually test against a specific magical experience that you built, now you need to have proactive protection against leaking PII, generating toxic responses, answering questions that that the chatbot is hallucinating answers to. You want to just protect against bad performance, because in many cases it's better to return nothing than something wrong. And then lastly, once you have a working application being tested and used by customers, then you want to curate that usage data and feedback to refine your performance. So let's walk through some of these steps to imbue your LM system with better safety and reliability throughout the entire development journey. So within the first step of getting it working, you have your LM application, you have your prompt templates, you have your documents that you're retrieving to put into your retrieve context, and you generate a set of outputs for your application. How do you actually ensure that every step is working? Whether it's the prompt template, the prompt variables, the retrieval or function calling step, or oftentimes with agents, you need a routing step. The first step is adding observability to your application, because observability gives you visibility. You can't judge what you can't see. If you don't have visibility into your tool calls or the variables that you're calling those functions with, or what the tool is actually returning, or what your retriever is generating, or what embedding you're using, you really need every single level of visibility into your application, essentially as like a full stack trace of logs for your LM app. Next, you have your working demo. You have a set of outputs that you can generate because you've built your LM customer support chatbot. You need to figure out a way to actually measure performance. So you can start generating scores for relevance, hallucination, and latency using your observability tool and manually annotating whether or not it hallucinated or not, whether or not it was relevant or not. But if you only have these metrics for a small set of cases, you don't have a reliable signal of whether it will work in the wild, in production, against many different kinds of questions and queries. So you need to be able to have a good evaluator as the first step. You need to have an evaluation prompt template, which you can use to run against a variety of different output metrics, or a variety of different data points in your data set to generate a label like relevant, not relevant, with a given explanation. And once you have your evaluator, you need a good evaluation process. You need a set of examples that you've curated to test against a certain kind of thing you want to guard against, whether it's toxic responses or trying to book a hotel in Georgia versus Virginia, where you can now track those changes as an experiment. You can change your model, change your prompt, change the context that you're loading and then run that new LM prompt against the same data and then get an evaluation score. So that way you can constantly iterate and improve and have confidence in your application. You can evaluate your application on multiple levels, right? So we constantly talked about at the beginning of evaluating your input versus your retrieval versus your output versus even the session where you can judge whether or not the user is frustrated or not. And then you can run these tests on every build in your CI/CD pipeline. So you're constantly testing your application for reliability on every change. And you can even create self-improving systems where you have your data set of examples, which can be generated via your LM. You can determine a different set of assertions and evaluation criteria using your LLMs to be more or less specific, to use code-based validators or LM-based qualitative evaluation. And then you can use human annotations to make corrections when it's gone wrong or already, so that way when you tune your prompts and you're retrieving sets of examples to you can add few shot examples to make the prompts perform better on the various different use cases that you have. And then once you have your application in production, you can add a guardrails step where you can make sure that for this example, where there's PII within the output, there's a user frustrated query, or there's a detected hallucination. You can actually use either code-based, embeddings-based, or LM-based validator to protect against responding to users in production. This is a step that you would add to essentially guarantee some level of protection against returning bad outputs to a user. Then if every time you detect one of these bad responses, you can either ask it to retry, you can send a default response, or you can just block it from responding at all. So we have a partnership with Guardrails AI at Arise, and we really like all the different kinds of validators that they offer. And they offer more than 50 validators across all three approaches. And using Arise, you can actually load the data from your traces and spans as the data set that you use for those embeddings or LM validations. And lastly, once you're trying to improve the performance of your application in production, you can expand the robustness of your data sets of the different types of test cases that you're validating. So on the left, you have different spans, either in a table view or within an embedding space view for clustering-based purposes. And then you can use Arise to either use LM analysis to actually find you examples of frustrated user queries. You could use embeddings to find points similar to a specific kind of query. Let's say they're asking specifically about pricing, or there's all these queries in a different language, or you could just use plain old filtering to then create your curated data set to then use for continuous testing on future deployments of your application. So in summary, we at Arise are trying to help you build better AI throughout the entire development lifecycle, from observability in your application when you're just getting started, to iterating on your LLM app and using evaluation and data sets, and even our prompt playground to help you get to a robust, reliable first version of your application, and then helping you guard against bad and problematic responses in production, as well as helping you find the relevant data points to continuously improve your application in the future. We also have many open source offerings. We love open source, from using open telemetry for actually tracing your application to open inference, which standardizes all of the different model providers and model calls and frameworks to a specific standard. And then an open source product to actually view your trace tree and run evaluations for your application. So that's my talk. Thank you so much, and happy building.